Hello YouTube. This is a tutorial on how to create large numbers. I'm doing this, my cousin is recording as I do something special. So we decided to do this, and there's three main methods and we will go over them. Here's the first one. A method 1, it's n-illion. There's the name and the number as zeros. For instance, a million has 6 zeros, a billion has 9, a trillion has 12, quadrillion, quintillion, but those don't actually matter too much. The really important thing is n-illion. That is a 1 with 3 times n plus 1 zeros. For instance, a million is a 1-illion, a billion is a 2-illion. Plug in the values of n, 1 and 2, and it should work out. If it doesn't, you did something wrong. You can do 6-illion, that comes after this. 3 times 7, that's 21. And it also doesn't really roll off the tongue very well. So you can say as 6-tillion or 6-illion, or you can just write it without ever saying it. And a good number to bring up right now is the Avogadro's number. And if you work in a chemistry or science class, you might have heard of this. But whether you heard of it or not, it is 606-illion. 6-illion has 21 zeros. This adds 2 extra, so that's 23. It's the number of atoms in a mole of any substance. A mole is a specific unit. That's the first method with n-illion. Then there's a second method, the googol-n-plex. And we don't have a very good camera, so sorry about that. There's a name and the number as zeros. A googol, for instance, is a 1 with 100 zeros. A googol-plex is a googol zeros. 1 with 100 zeros and 1 with that many zeros. Too big to write, even if you could live a million times longer. And there's a googol-duplex, a 1 with a googol-plex zeros. An unthinkably huge number, googol-plex, how many zeros? And then it gets even bigger. A googol-triplex has a googol-duplex zeros, and a googol-n-plex has googol-n-1plex zeros. For instance, a googol-plex is a googol-1plex, and a googol-duplex is a googol-2plex. And again, there's names after this, but they don't usually matter. And another interesting number to bring up is Skew's number that has to do with prime numbers. Skew's number is a 1 with x zeros, when x is a 1 with y zeros, and y is a 1 with 34 zeros. So you can imagine 1 with 34 zeros, 1 with that many zeros, and 1 with that many zeros. And Skew's problem has actually been simplified. That's not the actual answer, it's been smaller. If you're wondering where these names come from, they're the last name of the person who invented it. So that's method 2. It's much better than method 1 because a googol-10-plex is much bigger than a 10-illion. And then there comes method 3, arrow notation. It gets big numbers the fastest, although it is kind of hard to explain. So if you know powers, you know a arrow b is a to the power of b, or a times a, b times. So 2 arrow 4 is 2 to the power of 4. So that's 2 multiplied by itself 4 times. That would be 2 times 2. Start to work it out. Now it's preferred right to left, although you don't have to. So that's 2 times 2 times 4. And keep working. It's 2 times 8, and that's 16. That's single arrow, which is copying off of powers. Then there's double arrows. A double arrow b is a arrowed by itself, b times. And so 2 double arrow 4 is 2 arrowed 4 times. That's, you start to work it out, and you have to do it right to left this time. So 2 arrow 2 arrow 4. Again, that's 2 arrow 16. Or perhaps 65,536. And there's triple arrows. That's repeated use of double arrows. A triple arrow B is A double arrowed B times, so 2 triple arrow 4 is 2 arrow by itself 4 times. And you work it out right to left. That's 2 arrowed by itself 65,536 times. Or approximately a googol 65,531 plex. And then the interesting number to bring up this time is the biggest one with a name, and that is Graham's number. That's G64. G1 is 3 quadruple row 4, 3 quadruple row 3. G2 is 3 with G1 zeros, followed by a 3. G3 has G2 arrows, and then you go on to G64. And that is the biggest number with a name so far. And it deals with cubes of multiple dimensions, like 4-dimensional and 5 and so on. And the actual answer has a Graham's number of dimensions, so that would be super hard. So, thanks for watching the tutorial on how to create large numbers, and I hope you liked it. Bye.